Hello guys, so today we are here to solve a very famous problem called majority element. This problem is, it is often asked in the interviews, and this problem can be solved in very many ways. And our interest today is, to explore this problem. So to explore this problem, let's go through this problem, what this problem is saying. Okay, so in this problem, we are given an array nums of size n. We are given an array nums of size n, and we have to return the majority element. Okay, so it is not saying what kind of array is this. Every array, at least in Java, it should have a type. Okay, all statically typed language, the array should have a type. Okay, the majority element is the element that appears more than floor of n by 2 times. Okay, and as a condition to this problem, it is stated that we may assume that the majority element always exists in the array. So all the input cases are such that that majority element is always there in the array. Okay, and so the thing is that we have been given an array nums, and that array size is n. Okay, and we have to return the majority element, and then it specifies what is a majority element. The majority element is that element which appears more than floor of n by 2 times. So what is floor of n by 2? So if we divide n by 2, then that number is going to have some integral value and some floating point value. So whatever comes after the decimal is the floating point value. The problem is saying that you need to discard that floating point values and just consider the integral value. So that is floor of n by 2. Okay, and but see, in the problem statement it is not mentioned what is the type of the array is. So that's okay. If we go to the function that has been given to us, which you have to complete, in this it is clearly mentioned that the nums is a array of type int. Okay, so now we need to the clarity is there in front of us that this array is of type int only. So with this understanding, we will try to solve this problem. So first of all, what we will do that we'll take this n is equal to nums dot length. Okay, and then what we will do as a first approach, we will create a map of integer and integer. So first integer is the particular element of the array, and okay, and then what we'll do that we will go through all the elements of the array nums, and we will do map dot put, and input what we'll do I, and map dot get or default will again put I, and then by default if I is not there, then we'll be returning 0. So second parameter is the default value that we are going to return if I is not present. If it is present, if I is present as an entry in the map, then we'll be returning the corresponding value which corresponds to I, and that value again will be returned by incrementing it. Okay, so new association of I will be with the incremented value. If it is not there, then we'll be putting 1. Now after populating this map, what we will do that we'll go through the this entries of the so we'll go through the map dot entry, and this entry will be of integer entry is equal to map dot entry set, like this. Okay, so this entry set is there, and what we will do that if entry, if any entries get value, okay, this value is greater than, so we will define one variable called threshold. Okay, so we can do it here itself. Okay, int n, int threshold is equal to n by 2. Okay, so we don't need to use math dot floor here. Okay, we don't need to do it. Okay, why? Because by definition the integral division of two int numbers, n is an int number, 2 is also an int number, and integral division of two int numbers is going to discard the floating point values, and by default the value which will be returned is the floor of n by 2. So we did not consider that, and if it is greater than threshold, then we will return that corresponding entry key. Okay, entry dot get key. Okay, otherwise we will return -1. So this -1 case will not be coming, it will not be happening, because it is mentioned here that the majority element always exists in the array. So if we run this solution, what will be seeing? So this is accepting, and now if we submit it, okay, so this is running fine, and complexity of it is big of n, perfect. Okay, but see, the time it's taking is 13 millisecond. This we need to consider. Okay, why it is big of n? Because here we are going through every entry. So this part is big O of n, and this part, supposing if there is an element which is occurring more than n by 2 times, then at least we are going through this array, this entries, number of entries will be at most will be n by 2. Okay, at most will be n by 2. Okay, because it should be less than n by 2. Okay, so by for our convenience we are taking it as n by 2. Okay, and this big O of n and big O of n by 2, so in total it is the combination of that will be big O of n only, and that's why the complexity of this is big O of n. Okay, but now if we think that can we do something else about this problem? Okay, so I think definitely we can do something else also with this problem. Okay, so if we remove this, what can we do? So there is this observation about this problem, that in this problem, okay, let's think of this as a voting scenario. Okay, so majority element is that which is having more than 51% of the vote share. Okay, so int vote is equal to 0. So right now at the beginning of the voting there is no vote, and let's say one candidate we are taking. Okay, and that candidate is, as of now for initialization purpose, we are initializing it with -1, because that shows that this candidate is not there. And then int I is we are looping through for using for each loop through the nums array. And then what we are doing that we take if count if vote is equal to 0. So if there is no vote, okay, then let's say first candidate which comes, this candidate could be the winning candidate. Okay, then we'll take this candidate is equal to I. Okay, and increment its vote by ++ vote. Okay, else what we'll do, so if vote is 0, then this will happen, and then at the next iteration vote is not equal to 0. Okay, now vote is not equal to 0, vote is something, some other value. Okay, so vote plus is equal to, if the new value of I, okay, if the new value of I is equal to the candidate, okay, is equal to the candidate, then what we'll do that we will increment the previous value which was stored in the vote by 1. Otherwise what we will do, that we will do -1. Okay, like this. Okay, And if we do this, this will be resulting in a, okay, this will be resulting in you know, suppose, let's say second time around, let's say, second time around when we come to this array, okay, that element is not, you know, equal to the previous thing, okay, so then what will become 0, okay, suppose, the array is like this, okay, suppose the array is, like this. So first is 1, second is 2, and then 3, 3, 3, 3, 3, 3, 3. All threes are there. Okay. So first, in the first iteration, vote is equal to 0, candidate will be 1, and vote will be 1. Okay, and then the iteration will end. Then it will come to the second iteration. Second iteration, vote is not equal to 0. It will come down to the else part, and it will be assuming that okay, 1 is our candidate. So if 1 is equal to the next value of I, which is 2, if it is equal to 2, but that is not, but if it is equal to 2, then we'll be incrementing its vote share, okay, incrementing its vote count, but it is not, so vote will be again decremented. So now these two elements are out of consideration, okay. So this line is, removing two elements if candidate is not equal to I, then we are removing the candidate and I as well, okay. But if they are equal, then but if they are equal, then okay, then the vote will be incremented, okay. So in the second iteration, these two elements will be gone, and then from the third iteration we'll be, taking this, and then finally we'll be returning the candidate. So this solution is basically based on an observation that, if we remove two different elements from an array, okay, then after this removal, the majority element of the array remains the same, okay. So this is the, this solution is based on this observation, and since we are looping through this array only once, this is big O of one solution, big O of n solution, okay, not one, big O of n solution, okay, sorry, big O of n solution, n, okay. So this big O of n solution, let's run this and see what's happening here. Oh my goodness. Perfect. So see, this is 1 millisecond, this is 99.78, and this complexity is big O of n, okay. So that's okay. Okay, now we will, we will go to, another approach, okay, and this approach is based on randomized algorithm, okay. So we will, remove this, okay, cancel it, okay. We will, what we'll do that, we'll delete all this, okay. This thing is also not required, okay. Okay, so what we'll do that, we'll take n is equal to nums dot length, okay, n is equal to nums dot length and random is equal to new random. Okay, and then what we'll do that, while will take while true. So in this what we'll do, we'll be taking one int random int, okay, in between 0 and so random dot next int, and at most it could be of size n. Okay, so when we are passing this n, it means the value which we'll be getting back as in between 0 to n minus 1. Okay, and then what we will see, we will put one if count overall. Okay, count overall is for in this nums. Okay, and then this random int and then here what we'll do that we'll pass this threshold which is equal to n by 2. Okay, so this is threshold. Okay, and if this is there, then what we'll do that we'll return nums of random int. So we need to write this count overall function. Okay, and if we do that, then our problem is solved. So private int count overall, and we will be passing this int array nums. Okay, and then int index. Okay, and then int threshold. Okay, so first of all we will be taking this candidate is equal to nums of index. Okay, and then what we'll be doing that we will be going through this for loop. In this for loop, what we'll be doing that we'll be taking I is equal to 0, I less than n plus I. Okay, and what we'll be doing up in this for loop, or we don't need to use this for loop, we can directly use this nums for each loop. And in this what we'll do that if candidate is equal to I. Okay, so we will be taking one count is equal to 0, we'll be incrementing this count. Okay, and then what we will be doing that we'll be doing a return. Okay, threshold if count is it should be more than the threshold. So if count is more than the threshold, then we'll be returning true. Okay, and when we are returning true, so that random int we are returning back. Okay, so this is the way to solve this problem. Will it work? Let's run through this solution and check whether this is going to work or not. Count overall int cannot be converted to boolean if it should be boolean. Perfect. So see, this is the beauty of this randomized algorithm. Okay, this solution, one time it is running 99.78, it's beating other solutions, but if we run it again, it may not be running with the same efficiency. So let's check it out. Okay, so this is also, it's now also it's running with the same efficiency, but it's not, you know, necessary that it will be running with the same efficiency. You know, here it's running with the same efficiency, but you know, we can solve this problem in, you know, one more way. And this I would like to demonstrate, you know, that how can we solve this problem in one more way. So what we will be doing that, you know, we'll be going through this thing, and then what we will be doing that, you know, we'll be taking this return, and then we'll be calling this majority function. In this majority function, we'll be passing this nums and the end of the array. So end of the array is nums dot length. Why we are taking nums dot length? Why we are not taking nums dot length minus 1? This will be clear in next few lines. Private int majority, okay, and then int array nums, int start, int end, okay. And then what we'll be doing, if nums of start is equal to nums of end minus 1. So see, nums dot length is outside the array bounds, okay, so end minus 1 is the last element, okay. So then we can return nums of start or end minus 1. So we'll be returning end minus 1, okay. We can return nums of start also. So just in, you know, comments we can mention that nums dot start will also work as they are the same. Yeah, obviously it's same, okay. Now if this is not the case, okay, this is the base case, okay, if this is not the thing, then what we will be doing that, you know, we will be, you know, calling our recursion fairy, okay. Recursion fairy will be doing the work for us, okay, and we'll be passing this nums start, okay. And so to call this recursion fairy, we need to, you know, have this mid, and mid will be start plus end, okay. Okay, start plus mid, and here it will be mid. So this mid will be excluded, okay. And so this is the left half of the array. So this is going to return the left majority. Left half of the array, what element is the majority? This is the left majority. Int right majority, and this will be same as the previous because we are, you know, this is recursive call, and then it will be mid. Why it is the mid? Because here it will be going till the you know, boundaries are start to mid, but we only need to consider mid minus 1. But here the start is mid, so this mid is included and this mid is excluded. In here the mid is excluded and here the mid is included, and mid comma end, and mid end is this end, which is this nums dot length value. So this end is also excluded, okay. So this mid is excluded and this end is excluded because we are only, you know, bothered about end minus 1, okay. And that is the reason, you know, we take one index beyond the array, array's last index, okay. And if the recursion fairy is returning us, you know, same value for left majority is equal to right majority, okay, then we can either return left majority or right majority, not an issue. So I am not a leftist, I hate leftists. Right majority, it's okay. Now right majority I'm returning, though they are the same values, okay, it doesn't matter, okay, if I don't want to offend anyone also. So let's write left majority, okay. Now this is the, you know, this is the breakup, okay. This is the, you know, divide part. This part is the divide part, you know, here is the divide part, okay. We can say that, you know, here we are dividing the array, okay, and this is the divide part of the divide and conquer algorithm. Okay, now we need to return, if left majority and right majority are not the same, then what we need to do? Then, we are left with no other choice. Okay, what we are left, that, we should count the, what is the count of left count is the count of left majority, left count is the count of left majority. And what we'll be doing, we'll be writing one count overall, and this count overall will be, taking this nums, taking this left majority. Okay, left majority, and then it will be taking this, start and then end. So this is overall, that's why I'm calling it as overall. Okay, it's not restricted to this, divided part, it's going to count overall. So this is the left count. Okay, because this left majority and right majority are not same, that's why we are forced to go through the overall length of the array. And same thing we need to do for the right count. Okay, and this right count is the count of the right majority. Okay, so this again is the same function. Okay, and this is the right majority. Okay, now if as a result, if you are getting if left count is greater than right count, okay, right count, then obviously, left majority is the major element. Otherwise, if left majority and right majority are equal, then also we can return anything. And otherwise, in that case, we'll return, otherwise, I mean to say, if right count is greater than left count, we'll be returning right count. And if they are equal also, then we can either return left majority or right majority. But we can, I will be returning majority, and we will be, either we can return right majority or left majority, but here in this case we are returning right majority because they are the same, so it doesn't matter. Okay, we can remove this. Okay, and now the thing that is left to us is, we need to give a count of overall this. So private int count overall. Okay, and in this we will be doing int array nums, int left majority, or we can just write it as candidate. Okay, and then it is the start index, and then it is the end index. So what we will do that, we will take a count, and this count is equal to 0 for int I is equal to start, I is less than end. Remember, end is the excluded, so end is the, beyond the array limits, and that's why it is excluded. So last index will be end minus 1. That's why we are, restricting ourselves to I less than end, not equal to end. Okay, and then plus I, and then what we will be doing, if candidate is equal to nums of I, okay, we will be incrementing this count. Okay, and then this count will be returning. Okay, perfect. Okay, so this is the divide part, and then here is the, after this is the merging thing. Okay, so this is not exactly merging in the sense of, merging the two things, but out of the two values that, we are getting left majority and right majority, we have to choose which one is actually overall, the highest. So, now instead of focusing on the left half, right half, we are focusing on the overall, overall length of the array, and that's what we are doing. So let's see if we run this, what we are going to get. Maybe some errors. Oh my goodness, it's accepting in the first place itself. Perfect. Now if we run this, submit this, then what's going to happen? It's a wrong answer. It's outputting 10, but it should output correct. Left count is greater than right count. Okay, start and correct. Nums int candidate. start and I is equal to start and date is equal to nums of I, correct, plus plus count, return count is 0, perfect, this is correct. Start end, okay, start mid end, okay, this is also correct. Majority is equal to, right, majority is, oh oh, we don't have to do it like this. We have to do nums of start is equal to nums of is equal to end minus 1, not like this. Perfect, use this test case as also. Perfect, perfect. So this is the solution which I wanted to demonstrate. Okay, okay, so this is a perfect example of divide and conquer algorithm. Okay, okay, so we can as we have seen, we can solve this problem in many different ways. And what is surprising about this, though it is taking recursion, okay, here we are doing this recursion, okay, we are indulging in recursion, okay, recursive call on left half, and here also it is recursive call on the right half, okay. Even then, and see, this is, and this we are going through the total length and breadth, count overall is going so many times this will be called, okay. you know Obviously this is going to be big of the size of the start end minus start plus 1, and this is also big of n only, okay, and where n is end minus start plus 1. And even then, this is so fast, okay. And if we click on what is the complexity of this, so since this is a divide and conquer algorithm and recursive algorithm, we have to do master theorem to, and this is obviously this is coming as big of n log n, okay, which is obvious, okay, because it is it is in similar way that merge sort and other algorithms are there, which are great examples of divide and conquer algorithm. So it follows the same thing, and even then this is beating so many. So this is purely because the uh, test cases are not well designed, otherwise this solution should not be this fast. But this is interesting solution, and this has great learning you know value, at least in my mind. I hope you enjoyed this. With this, I would like to thank one and all. Happy coding, best wishes, keep enjoying.